Okay, we're recording. Hi, everyone. My name is Gianni Crivello. I'm super bummed that I wasn't able to be there today, but you're in great hands with my co-founder. So let me just jump right in, right? What do we mean by AI payments? Well, this is a talk about AI payments, but what we really mean is that this is a talk about AI initiated payments, right? My AI system makes a call to some function and then we facilitate payment. Well, this isn't super interesting because this is just function calls, and I'd argue that payments is pretty much a solved problem. We have traditional payment rails, and then we also have blockchains, and blockchains are facilitating really creative ways to move money. There's payments is solved, I would say, and so we have LLMs that call functions pretty well, and we solve payments. So are we done? And no, fortunately I don't think we're done, right? This is actually a super exciting space and totally non-trivial. And here's why. The question boils down to how does trust scale in these systems? I think majority of the interesting work and foundational work will be done on trust protocols. And well, here's an example. I want my agent that has access to my money to perform some long-running task, and hopefully it doesn't get hacked along the way and drain my bank account. So before we get into the weeds, I think it's important to call out. I feel like sometimes we forget this as engineers. We're building these systems for humans to make human lives better. So we could solve the trust problem by just massively inconveniencing our users, right? Who cares? We can say users need to stay behind the browser and explicitly approve or deny every action. And I don't think that that's enough, right? It's the same reason we have session cookie. We stay logged into apps we use every day so that we aren't inconvenienced by any sort of login flow. I would hate every single time I go to the app that I use every day that I'd have to log in. And so when I talk about how trust scales, well, we shouldn't just build systems for the sake of building them. We know this. But we also shouldn't just lock them down so that they're unusable. Right? It's how we model these systems so that they're safe, but like as important is that they're nice to use for our users. You have the safest system in the world. If no one wants to use it, then that doesn't provide any value. And so this is a talk about AI payments, I promise. But this is also a talk about trust protocols for agent workloads. It's actually mainly a talk about trust protocols for agent workloads with AI payments is a super solid first use case. And so some housekeeping. We can't cover everything in the time that I have. I'm going to do my best to go over the important parts, but if you're really interested in the work that we're doing or want to contribute, I created a Discord for this project. You can also go to our GitHub. Come ask questions, please. Everything is open source. The demos you see, the protocol, this presentation, everything will be available to anyone who wants it. And if I butcher something, let me know. Help us get better. Please, you can contribute. And fraud is also still possible. I just want to put that out there, that we're talking about trust protocols. If you are getting into payments, you do still need to think about underwriting. And in the world of agents, like that's not clear. So if you're getting into AI payments, come talk to us. We might be able to help. So this is like a simple view of the world. Actually, let me move my... Oops. That's not what I wanted. There we go. Okay, so this is a simple view of our world. We have a user, we have an agent, and we have a merchant. In this case, you can just think of a merchant as an MCP server. You have payment protocols that facilitate transactions, and then you have trust protocols. I'm not going to talk about payment protocols. If you're interested in that stuff, X402 is awesome. Big ups to the guys at Coinbase. I think that the work that they're doing is really moving the web forward. So let's just assume that payment rails and payment protocols exist, and as soon as we get over the hump there and we pass it off to some facilitator, all of that's out of scope for this talk, and it's safe, right? What I'm going to talk about today is the interaction layer, right? Like the trust protocol, the interaction between a user and an agent, how information gets relayed back and forth, and when we do give an agent explicit consent, how long should that consent last? And so we do have examples of trust protocols in the world, right? Like OAuth exists. Why do we need more protocols? And quite frankly, like it's important that we understand how OAuth works so that we can justify new protocols, because OAuth does solve a lot of these problems. So we're going to get into the weeds with OAuth here, right? So we have 3 actors, and I apologize if you guys already know this, but it's important that we all are speaking the same language, right? So we have 3 actors. We have a browser, a server, and an IDP stands for identity provider. You can think of this as just Google. Well, what will happen is the browser wants to authenticate with the server, so the browser makes a call to our server at a login URL. The server will respond with a redirect, a 307 redirect. The browser is then redirected over to our identity provider with a URL and a bunch of URL parameters. I highlighted redirect because it's pretty intuitive. The identity provider needs to know where the server is that the client wants access to. The identity provider will then call our callback on the server with a code. You don't really need to worry about what the code is, just know that there's a code and it gets passed over the wire. And this is also why when we implement auth in our applications, we always need a callback endpoint. And then what the server will do is we'll take that code and make another post request to the token endpoint that's on the identity provider. The identity provider is what mints the actual tokens, and these are special tokens, right? So finally, what we get back when we mint a token is what we call an ID token, and this is a JWT token. It has information that the identity provider keeps about me: my name, my profile picture, my email. Then what we'll do is we'll take this information and we'll create our own JWT with application-specific fields. This is known as token translation, right? So we'll take this ID token, we'll wrap it in our own fields, and then mint our own token. This is a common misconception, right? There's an ID token, and it's not. It shouldn't be, right? It shouldn't be the token that you send down to your client. You have a JWT token that you create internally within the server, and then you pass down to the client. Finally, right now the browser can make authenticated requests to the server, and we can ditch the identity provider altogether. So let's make this real. I'm going to switch over to a demo here. I gave you guys already a hint here. So we have this. We'll log in. So I will go to my login endpoint. I will be redirected to Google's consent screen. I'll log in, and then now I'm redirected back to my application. My application creates a token and then sends it down to my browser, my user here. And so when I grab this token and go to my trusted JSON web decoder, I can paste it, and I can see when I decode the payload that this is my application-specific fields that and knowledge about my user, right? So I'll have the email, the role of this user in my application, and then the user ID. All right, so how do we model this in AI apps, right? Well, your browser tells your agent that maybe you need cat photos ASAP. Now, the MCP server will have a tool to serve cat photos. Right, this is just a TypeScript MCP server, defined a tool, get cat photo, returns random cat photo. Okay, well, the agent takes your request from your browser and passes the token along to the MCP server. My face is messing that up too. No, there you go, perfect. So passes it along to the MCP server. And now here's the question, right? Like the MCP server knows who the user is, but doesn't know who the agent is, right? Remember, this JWT token contains information about the end user, not the agent. So should the agent be treated as the user it's requesting resources on behalf of? I don't know. Well, I mean, hey, it's a little broken. We get back the cat photo. Who cares, right? Like, this is fine for this use case. And I agree. Let's not over-engineer. Well, what if there is another tool on the server and this is get premium cat photos and these photos are way better than the free ones? Well, here's what we know, right? We know that the MCP server knows who the end user is because we passed that token, not who the agent is. And we could encode application-specific permissions into our JWT, right? So like we could encode that this user is a premium user and is allowed to make purchases on our server. That's fine. Who cares, right? Like it's a little broken again, but right? Like who cares? Works. Well, what if things get a little more complicated? And unfortunately, they do, right? Things get more complex. Our users demand way more of our applications, and everyone in this room is pushing the boundaries of what's possible with AI. So for example, I might tell an agent from my browser, hey, take my Pinterest inspiration, a photo of my living room, my budget, and a bunch of links, and like plan a renovation for my living room. And I'm gonna actually just go away, right? So no more browser involved. I close my laptop, I just walk away. And I'm expecting this agent to perform a long running task. Could take a couple hours, could take a day, right? And in this case, we have an MCP server with two tools, one for add to cart and one for checkout. And so I want my agent, and this is how I'm modeling this application, to make multiple calls to the add to cart and then make a call to checkout. And I want to model that when I make a call to checkout, it hits a tripwire and it needs to go reach back out to its user. By the way, there's no browser, so we need to now send an SMS, and the message needs to be clear. I want to spend your money, and here's what the shopping cart looks like. And of course, like this cart could be huge, right? Spending potentially thousands of dollars. We sure don't want the agent to make purchases without the user consent, right? So stakes are high. Well, you know, how do we do this, right? I want to ensure that the agent spends my money if and only if I give it explicit consent to. Well, notice that we have two functions on this MCP server, right? And they have massively different implications. For my add to cart tool, I'm totally cool with adding as many items to my cart as possible. Go ahead, add away, more the merrier. I like options. Don't bother me, right? You can call this function freely. But my checkout tool, well, I need to ensure that my agent will never spend my money without my explicit consent, especially within this application where these carts could be really, really large. Furthermore, when I do give my agent consent, how long should that consent last? Right? I have a long-lived JWT. We remember, we know how to do that. We know how to get long-lived JWT tokens to authenticate the end user. But, you know, you probably shouldn't encode in a long-lived token the permissions to check out, right? What if I give this agent permissions to check out now? Well, that doesn't mean like it should check back with me the next time it wants to make a checkout, right? Especially in this application. So I'd argue that it should be like a very short-lived token, probably scoped to just within that transaction. So unfortunately, like we've totally borked our model of the world, right? OAuth is not going to be able to support this within our application at least, right? OAuth was really made for humans to log into apps. And the user experience of OAuth is like, let's keep a user logged into the application they use for as long as possible, which is an industry standard experience, right? Like I expect that from my applications. I don't want to be like logged out of my apps, right? It's an inconvenience. It's a user experience though. And this is what our users expect. So this is great. Long-lived JWT token, awesome. It is absolutely not where we should be encoding authorization for agents for tools that can be potentially catastrophic. right? And this is where I'm going to introduce a new protocol that you've probably not heard of. It's called GNAP, right? And so GNAP stands for Grant Negotiation Authorization Protocol. It's an IETF standard. There's an RFC for it. It's key-bound tokens, which means that there can't be a man-in-the-middle attack. I can't steal your token and use it to make as many checkouts as I want, right? It's the token is bound to a private key that exists on my device, likely in a secure enclave. It supports really flexible use cases, right? And let me move my head again. It supports flexible use cases where a user or resource owner is not the end user, right? So when would you want that? Well, healthcare is when you would want that, right? Where an agent is releasing medical records to a user, although the user owns the information in those medical records, the records themselves are owned by someone else, likely your doctor. It answers the question, finally, of who an agent is in our system and what that agent is allowed to do. And it's short-lived tokens, right? Like this supports short-lived tokens. I just want to scope the permissions of checkout for that specific transaction. So let's walk through the GNAP flow. And hopefully my head doesn't get, oh, it does. Let me make myself smaller. There. Oh, cool. Okay. So for the sake of the example, we'll model a GPU service provider providing resources to an agent who belongs to a logistics company. So there's 4 actors, right? There's a resource server, which is also, for all intents and purposes, it's an MCP server. We have the authorization server. In this case, it's a third-party service, which is why they're different colors. And then we have the agent and its user, which belong to the same party. We start by giving the agent a request. So boss of logistics company tells its agent, or his agent, go perform some long-running inventory management task. The agent will then make a call out to a resource server. You can think of it as like a GET request to a tool, and then you have query parameters that get passed. Great. Now, because this is a GNAP MCP server, we return a status code 401 unauthorized with some information on what the agent needs to access this resource. So the resource server knows that, okay, this agent is not authorized. Here's what you just called this endpoint. Here's what you need to be able to successfully call this endpoint. I need type payment, a resource ID, and the actions required. Now, if you wanted to get fancy, this is also where you could plug a status 402, by the way, payment required. So the agent will then make a grant request to the third-party services authorization server. It's going to say, here's my public key, here's the access I need, here are the constraints of my access. So in this case, we can add, okay, not only this is what you're going to do on this server, but here are the constraints. You're only going to spend to this amount, here's the currency, here's the merchant ID. What this is going to do is tell our agent how to communicate what it needs to its user and what to do while it waits. So we get 2 bits of information. The top field is continue. Continue tells the agent process where to poll for the status of the token and how long to wait in between polls. And then interact tells the agent what to communicate to the user. So in this case, it's a code at some device, hosted device URL. So the agent goes and tells its user, hey, go put this code at this URL, I'll wait. At this point, at each pull request, we get information back from the authorization server, right? So when we're still waiting for consent from the user, so the user's still waiting, we're still waiting for consent, we get back a temporary access token, and we also get back how long the process should go to sleep between the next poll. So in this case, our authorization server is communicating to our agent, the token is not ready, the user has not given us permission yet, sleep for 5 seconds and check back again. Finally, the user gives explicit consent. So when the user finally gives consent, the next post to the poll endpoint will be our short-lived JWT that has access the agent needs to perform its action. Right? So finally, we get back the short-lived key-bound token. Great, so now the agent can fulfill the user's requirement, right? We're gonna go back to the same tool, we're gonna pass back our GNAP token, and all is good in the world, we actually perform the transaction. So let's make this real. I'm gonna go to my Postman here. Let me make sure that this server is running. Okay, just fired up the server. So this is our, we're going to be communicating with an authorization server here. So here's the grants endpoint. Here's that information that I showed earlier, right? We have a client, we have the access that this agent needs. We have the payment, purchase, the actions that we want to complete under the constraints. So we'll send that off. Boom. And then what we do is we get back the 2 bits of information that tell us how to interact with the user and how to interact with the authorization server moving forward. So in this case, we'll go to this endpoint here. Take this. Let me just wire this up. We have an authorization. We have a GNAP. Let's pass in our GNAP token. And now when we make that, and it has to be a post request, when we make that post request to the continuation endpoint, we get back essentially the authorization server saying, hey, token's not ready yet, check back in 5. All right, so when we come back here, the agent is supposed to tell me how to give it consent, right? And so it's communicating with me, and I'm saying, okay, great. Take this code, go to this URL, and let me make sure that you can see that. Great, I'm pasting my code, I hit approve, and when we come back here, to our Postman, let's do this, when I pass in my headers, and I give it the actual post request. Great, we get back our access token that we were looking for, right? So this is the access token. When I select this, I come back to my trusty JWT debugger. Go back now. When I go back to our JWT debugger, I can paste that token in, and we can decode the payload and see that these are all of the access that we